Welcome to our journey through the life cycle of stars, where we'll explore the fascinating process of birth, evolution, and death that shapes these celestial objects. The birth of a star is a cosmic dance of matter and energy that unfolds over millions of years. It all begins in the silent depths of space, where vast, chilly clouds of gas and dust float aimlessly. These aren't just any clouds, though. They are molecular clouds, the very cradles of star formation. Imagine a cloud, 1 billion miles across, filled with tiny particles of dust and gas. Then something triggers a collapse. It could be a nearby supernova explosion, a collision with another cloud, or even a brush with a spiral arm of the galaxy. Whatever the cause, the result is a gravitational freefall. The cloud collapses under its own weight, and as it does, it fragments into smaller, denser clumps. Each clump continues to collapse, growing denser and hotter at its core. This is the birthplace of a future star, a protostar. The protostar is enshrouded by a cocoon of gas and dust, hiding it from prying eyes. But within this cocoon, a battle is raging. Gravity pulls material inward, while pressure from the heated core pushes outward. This cosmic tug-of-war is essential to the birth of a star. As the protostar grows, the heat and pressure in its core intensify. Then something extraordinary happens. The core becomes so hot, so pressurized, that hydrogen atoms begin to fuse together, forming helium. This process, called nuclear fusion, releases an incredible amount of energy. It's the same process that powers the sun and every other star in the universe. With the ignition of nuclear fusion, the protostar sheds its cocoon and emerges as a newborn star. This marks the beginning of its life on the main sequence, where it will spend most of its existence, burning hydrogen fuel in a steady, stable state. As the protostar grows, nuclear fusion ignites in its core, marking the beginning of its life as a star. Just like that, a new beacon of light has joined the cosmic ballet, ready to embark on its journey through the universe. For billions of years, a star remains stable on the main sequence, steadily burning hydrogen fuel into helium in its core. This stage of a star's life is a harmonious balance of forces. The inward pull of gravity is perfectly counteracted by the outward pressure from the energy produced by nuclear fusion. This fusion process transforms hydrogen into helium and releases a tremendous amount of energy in the form of light and heat. The light we see when we gaze up at the night sky is, in fact, energy produced by this fusion process. It's this energy that powers the star and supports it against the relentless crush of gravity. During this time, the star is in its prime, shining steadily and providing light and warmth to any planets that might orbit it. This phase, known as its adult phase, is where most stars spend the majority of their lives. As the star exhausts its hydrogen fuel, its core contracts and heats up, causing the outer layers to expand and cool. The star enters a new phase of its life, known as the red giant phase. This is a time of great change and transformation, a celestial metamorphosis, if you will. Picture, if you can, a celestial body previously stable and predictable, now swelling to monstrous proportions. The star's outer layers expand, ballooning outward in an awe-inspiring display of cosmic grandeur. But this isn't just a dramatic spectacle, it's a fundamental part of the star's life cycle. During this red giant phase, the star's outer shell continues to grow, reaching out into space. It might even become so large that it engulfs nearby planets, forever altering the dynamics of its solar system. Now that's quite a change, isn't it? But the red giant phase is more than just about expansion. It's also about transition, about shedding the old to make way for the new. As the star's outer layers continue to expand, they also start to lose their grip on the star. Slowly but surely, these layers are cast off, freed from the gravitational hold of the star. This is not a sudden event, but a gradual process, unfolding over tens of thousands of years. As the star sheds these outer layers, something magical happens. These layers of gas and dust form a glowing shell around the star, illuminated by the intense heat of the star's exposed core. This shell of material is what we call a planetary nebula, a celestial spectacle of color and light. Planetary nebulae are some of the most beautiful objects in the night sky, a testament to the star's past life and a herald of its future evolution. They're like cosmic butterflies emerging from the chrysalis of their red giant phase, ready to embark on the next stage of their celestial journey. Eventually, the star sheds its outer layers, forming a beautiful and colorful planetary nebula. It's a fitting end to this phase of the star's life, a brilliant display of cosmic artistry that serves as a poignant reminder of the star's journey and the inevitable cycle of stellar evolution. What remains of the star's core is a dense and hot stellar remnant known as a white dwarf. This marks the end of the star's evolution for low to medium mass stars like our Sun. But what becomes of these white dwarfs, these glowing embers of once fiery stars? Over billions of years, white dwarfs cool down and fade away, eventually becoming black dwarfs, silent witnesses to the grandeur of the cosmos. But let's shift our gaze to the more massive stars, those with a mass many times that of our Sun. Their life stories are far more dramatic, echoing with thunderous applause in the grand theater of the universe. As the core of a high-mass star exhausts its nuclear fuel, it undergoes a series of contractions and expansions. This stirs up a cosmic cocktail of elements from helium to iron. But iron is the end of the road in nuclear fusion. It doesn't release energy when fused, causing an imbalance. Without the outward pressure generated by fusion to counteract the inward pull of gravity, the core collapses under its own weight. This collapse triggers a cataclysmic explosion known as a supernova, outshining entire galaxies for a brief moment in cosmic time. What remains after this celestial pyrotechnic is a core so dense that a sugar cube-sized amount of its material would weigh as much as a mountain. This is a neutron star, a stellar remnant that packs twice the mass of the Sun into a sphere just about 20 kilometers across. But for the most massive stars, even the pressure from tightly packed neutrons can't halt the core's collapse. The core implodes to form a point of infinite density, known as a singularity, surrounded by a region from which not even light can escape. This is a black hole, one of the most mysterious and fascinating objects in the cosmos. The remnants of these explosions can form exotic objects like neutron stars and black holes, which continue to intrigue and inspire astronomers to this day. From white dwarfs to neutron stars, from supernovae to black holes, the life cycle of stars is a testament to the beauty and diversity of our universe.